All right, so as some of you may have noticed, we've actually done most of geometry already. We just got the trickier problems that we're saving for this week's module. All right, so we're going to start by talking about some circles. So a circle represents represents a cat. It represents a set of points, all of which are on the same distance from a fixed middle point called the center of the circle. Okay, so there's a center. Every single point is the radius distance away from the center. That's how circles are defined. Okay, so the diameter is the full distance across through the center, and the radius is, I guess, the half distance across. It's the distance from the middle to the outside. All right, so we got two formulas. Again, you're not going to have to memorize any formulas in this class, but one to find the circumference the whole way around, and one to find the area is the area of the inside. Okay, so we got them right here. Another one that you can use for circumference, right? Circumference is pi times the diameter, because the diameter is just twice the radius. Okay, so they are equivalent formulas. So if we want to find the diameter, the circumference, and the area, we use all that stuff. So remember, the diameter is twice the radius. So if 5 kilometers is the radius, then this whole thing is the diameter, and there's two radiuses. There's 2 times 5. It's going to be 10 kilometers. This whole thing is the diameter. Make sure to always include units. And we need the circumference. Well, now we can use either formula. 2 pi times the radius or pi times the diameter. So let's just plug in the radius of 5 kilometers. 2 times pi times 5. And now at this point, remember, you're going to have to use your calculator. And now you can use your own calculator if you want, or you can use Desmos. If we use Desmos, then what you're going to type is something like this. Just type pi. If you type pi, it automatically replaces it with pi on Desmos. And then the radius is 5. So 31.42 is how we'll approximate it. And again, be careful with your units. The diameter is a distance, so it's in kilometers. The circumference is also a distance. It's how far the whole way around is. So if you walked all the way around the circle, you'd walk about 31 kilometers. Okay, so that's good for the circumference. And now the area is pi times the radius squared. So that's going to be pi times r squared, 25 pi. You type that into a calculator, and you should get about 78.54. But this time, the area is not a distance. The area is not in kilometers. The area is an area. It's a region. So we're going to talk about square kilometers. All right. So be careful with these units on these ones. And you can have more complicated shapes too. Whenever you have more complicated shapes, a lot of times we can simplify them into easier shapes. So notice in this shape, this is just a semicircle and a rectangle. The semicircle has diameter of 20 inches, which means the semicircle has a radius of half of that, 10 inches. Okay, so if we have these two shapes, we can find the perimeter. The perimeter is going to be the perimeter of half of a circle. So it's going to be 1/2 perimeter of the circle plus the perimeter of the rectangle. So the perimeter of a circle is 2 pi r. And the perimeter of a rectangle is the sum of all the sides. Just going to write it again. And now what is our radius? Our radius of our circle is 10. What's the sum of all the sides? 42 plus 42 plus 20 plus 20. And then we'll use a calculator to simplify our answer. Or you can simplify a little bit by hand first. The 1/2 and the 2 cancel. So we get 10 pi plus 124 maybe. Let's just use a calculator, okay? And approximate it. So you can type the whole thing, right? The whole thing that we had above if you want. 1/2 times 2 pi times 10 plus 42 plus 42 plus 20 plus 20. That's what we had. And that's about 155.42. And then just be very careful, right? What are our units here? We're talking perimeter. So this is a length. Oh, I made a mistake here. What's the mistake? I'm counting this. We don't actually want the whole perimeter of the rectangle. We only want these 3 sides of the rectangle and then the semicircle. So this part up here is good, but this part, we don't want the whole rectangle, only 3 sides. So let's toss out that 20-inch top, like so, which is going to turn this into a 104. Just going to turn this into 135.42. Okay, inches. This is the perimeter of this, whatever shape that is. Okay, how long it takes us to walk all around? 42, 20, 42, and then like 31. Okay, I say okay a lot. Last off, area. The area will be the area of the semicircle plus the area of the rectangle. Okay, so area of the semicircle is going to be 1/2 the area of the circle, which is pi times the radius squared, and the area of the rectangle is going to be 42 times 20. Type this into a calculator and you should get your area. So if we go over to our calculator and type this in, let's see what we get. We're going to get 1/2 times pi. Ooh, careful right here. When we are in the fraction, make sure to tab out of the fraction. 1/2 times pi times 10 squared plus 42 times 20 should be about 997.08 is how you round. And that'll be inches squared. All right. And that's pretty much what we got here. Last problem is going to be very, very similar. So I'm going to not do all of the last problem. Let me know if you have questions about it. But I do want to talk about the triangle. So the semicircle part is going to be the same. But for the triangle, we need to find the area of this triangle. The area of a triangle is 1/2 the base times the height, but we don't know the height here. Okay, so we have to find the height. So if we look at this triangle, I'm going to flip it upside down. Right, this is 6 feet, this is 6 feet. We know that the whole base is 4 feet, so you can think it's 2 feet on each side. Well, now look, we have a right triangle. Right triangle right here. We know 2 of the sides. We need to find the third side, Pythagorean theorem. 2 squared plus h squared equals 6 squared. And you can use this to find h. Okay? So do the rest of this problem on your own. Let me know if you have questions, and good luck.